Okay, so if we go to our periodic table, and let's just say we're looking at carbon. You see carbon? Carbon has 6 protons. You see that at the bottom? Find carbon. Good. Carbon has 6 protons. And that number at the top, that number is the atomic mass. It's actually an average, all right? So its average atomic mass is 12. Now, where do you think all that weight is coming from? Hmm? It's coming from the nucleus. And what is in the nucleus? Protons and neutrons. What is outside the nucleus? Electrons are moving around and around outside the nucleus. So that decimal number, right, for carbon at 12.011, you see it? That's coming from the mass of the protons and the mass of the neutrons. Now the number at the bottom, see that number 6? We're just looking at carbon. That is just the number of protons. It is just the number of protons. So if I have the number of protons at the bottom, the number 6, see that? Number 6. And the number 12 is the number of protons and neutrons. Well, then how many neutrons do I have? I have the protons, which is the 6. And what would add to 6 to make 12.01? It would be 6 neutrons. All right? So this decimal number is called average atomic mass. Let's get closer to it. All right? And it's the number of protons and neutrons. Notice what happens when I go from 6 protons, see the 6, to 7, and then to 8, and then to 9. As the proton number changes, the element changes. So that's what I mean when I say protons identify. If the proton number changes, then the element changes. Now, neutrons. Well, what number on the periodic table in the carbon square is going to be affected by the number of neutrons? Is it going to be the 6? Oh, no, because that's just the number of protons. So it would have to be the number 12, all right? Neutrons affect, that's right, mass. They affect the atom's mass. Remember, all of the mass, the decimal numbers come from protons and neutrons, and what's moving outside? Electrons are moving outside. So, neutrons affect weight. I'm going to write that down. W-E-I-G-H-T. Please don't joke my handwriting, okay? It affects weight. Now, all of the carbon that we have on our planet doesn't have the same weight, just like every person on the planet doesn't weigh the same. So, we can have carbon 12, right? See that? Carbon 12. That's what's on the periodic table. We can also have carbon 13. Right? See that? We can have carbon 14. Okay? We could have carbon 15. Okay? Now these are things that happen in nature. How do people gain weight? It just happens. People start eating, got a little bit of burgers, a little bit of hot dogs, a little bit of fried chicken. All right, so things happen in nature to cause an atom to gain weight, and that weight comes from neutrons. Now, can I gain protons? Of course not. If I do, then I'm a different element. But if I gain neutrons, I'm the same element, just heavier. Okay? So whenever you see it notated like this is indicating a difference in the number of neutrons. This number, this 12, 13, 14, 15, is the mass number. So let's just look at carbon 14. Carbon 14 is carbon. So it has to have how many protons? How many? Good. It has to have 6. But if its mass number is 14, 14 is 6 plus what number? I have to have 6 protons to be carbon. So how many neutrons do I have? Hopefully you said 8. Because 6 plus 8 will give you 14. Okay? So that's what neutrons do. Neutrons add weight and affect an isotope. Okay? Last thing, and the most important, electrons. These bad boys are all that is involved in our chemical reactions. We got protons and neutrons in the nucleus, holding it down, adding weight to the atom, and moving around, we got electrons. Moving around, we got electrons. Moving around. You know what? That could be a song. All right? So, electrons, right? They're in orbitals. They're outside the nucleus. Well, Ms. Baldwin, what do? I'm going to tell you. They add something we call, can you see it? Charge. That's right. Electrons add charge. Okay? So, let's go back to the periodic table. And we're going to pick out lithium. Okay? Lithium. Can you see it? Do you see it? Do you see it? Do you see it? Lithium right there in the corner. How many protons? Good. 3. How many protons and neutrons? We're going to round that 6.9 to 7. Okay? So, if it has 3 protons, all right, having a difference in the number of electrons will cause the change in lithium's charge. Now, because of lithium's position on the periodic table, you should know by now that it is going to be a positive 1 charge. Everything in this column is a positive 1 charge. So when I write lithium plus 1, whenever you see it notated like that, it's indicating a charge. So does that mean that protons has changed? Of course not, because we would not be lithium. Does that mean that neutrons have changed? No, because the way we notate a change in neutrons would be something similar to this. When you have this, that's a key thing, that what has changed is the number of electrons. So, for lithium 1 plus, how many protons must I have? Look at the periodic table. How many protons must I have for lithium? Can you see it? There we go. Good. It has to be 3. Okay? So I'm going to have 3 positive charges. Now, how many electrons will I have if I have to end up with a positive 1 charge? I have to end up with 1 more proton than an electron. Good. Since it's a plus 1 charge, I have to have more pluses than minuses. I'm going to only have 2 electrons. I have 3 pluses, and I have 2 minuses. A plus and a minus cancel out. A plus and a minus cancel out. And I'm left with 1 positive, which is the charge of lithium. Okay? Just my little 2 cents. Hopefully this helped you on atomic structure. Don't forget, study, study, study. And hit me up if you have questions. Peace.